In this video, I want to go over the PhysicsController2D, which is the base class for character controllers such as enemy controller and like player controller, and discuss a few things about it. First off, the PhysicsController2D is basically a custom controller for integrating Unity's new low-level Physics 2D API introduced inside Unity 6.3. For anybody that doesn't know it, just heads up. Currently, the namespace is physics low level, but Unity is actually changing the namespace in 6.5 because Unity's low level physics is now becoming the Physics Core 2D API. It's the same API, they're just renaming it because it's now becoming the main physics backend for 2D physics. So this will be changing for anybody that sees this video in Unity 6.5. Anyways, PhysicsController2D is the abstract class that allows different objects, not just characters, it could be statues, it could be moving platforms and so forth, to have velocity interactions during physics, to also have different types of interactions in different environments. For example, we actually have a property called physics volume type. So you can actually set up new types of physics volume. At the current moment, I only have water, gravity, and then just like there's nothing affecting it at the moment. So you can actually have physics volume zones, and anything that derives from physics controller can actually have like a physics zones that either slow you down. So like, let's say you're going through like a heavy gravity field or reverse gravity field, or you're jumping into water and you move a little bit slower in water. So you have a little bit more linear drags moving and basically making it harder for whatever the controller's controlling to move. So PhysicsController2D takes care of that. I'll be adding air in the future. It also keeps track of the current physics. So basically you have your default physics movement properties, which is like your ground speed, running speed, and stuff like that. Depending on what you're setting up with a physics controller, if you might not need all these, but it is there if you need it. And current physics actually shows what is currently being processed into physics based on different modifiers. So for example, you walk into a gravity zone, and whenever you enter a physics volume, it actually allows you to override the current properties. So you can actually create a physics volume, and you can actually have make it where stuff like the gravity scale is higher. And basically current physics value tells you what the current active calculated physics being applied to a controller is. Do you know whenever you leave physics volume type, the current physics reverts back to the default physics. So that's why default physics there. You have direction, which is actually useful for many different things. For example, it keeps track of like when a PhysicsController2D changes directions. Say you have an enemy that is moving to the right, and then it changes to left, and you want something like a callback to change. There's actually an on direction change callback. So any class or object can actually listen to this callback, and whenever that physics controller turns left to right, it will actually call that. So that's another thing. I also keep track of the direction of the last frame and previous frame, which is useful for if you are actually using Unity's 2D sprites. I can actually show this here. So I'm actually going to go to a blood zombie. If you actually notice inside our sprite renderer, you see how it says flip X here. So watch what happens whenever zombie touches the wall. Notice how it switches over. So to no longer being flipped on the X-axis. So whenever a direction changes, one example usage is I just have it where the sprite renderer of the sprite is just changed and flipped over. So there's one usage. Another usage is hitboxes. I'm not kidding. You can actually just use this to switch over hitboxes. Like if you're swinging the sword to the left. So if I actually like swing down hitboxes to the right, but whenever I turn to the left with my character here, on direction will tell the game that, hey, the hitbox should now be facing to the left. So that's another use you can do for it. Also keep track of the calculated velocity. So this is the velocity for the current frame based on physics modifiers such as physics volume, whether you're falling, whether you're jumping, stuff like that. It also keeps track of external velocity for anybody that actually needs it. And basically what the external velocity is like gravitational forces that might override your current velocity. So think of it as an override. One use of that is, let's say your character jumps into a spring. You want it to immediately bounce in a certain direction. You can actually just override your calculated velocity by doing the external velocity, and it'll automatically do that for you. So you can do it for like springs, bouncy objects. Like for example, in my project, I actually have a jungle biome and there's mushrooms. Whenever you jump on the mushroom, you bounce up, and it's basically just setting the external velocity to a certain y value. Also keeps track of whether you're frozen. So if the character controller is frozen, basically the character is not moving on its own, like the velocity is frozen, but it can still interact with physics, which might be needed during cutscenes or so forth. You also have a set of functions that you can actually override. So like I said, physics controller is actually the abstract class. You can actually inherit from it and create your own. So for example, I have like a controller body that is actually used for characters specifically. So this is my kind of like my character thing. So you can see here I inherit from it, and I basically have custom overrides for this. One of the reasons why I did this is basically instead of it just being used for characters, you can use it for anything like elevators and different like puzzle mechanic that needs physics and so forth. Yeah. Basically, instead of overriding, if you do inherit from this class and you create your own, instead of overriding the start, you override the on start, and same thing with wake. Instead of overriding wake, you want to override on awake or on init. The reason why there is a init and then there is a on awake, you notice awake is private and then on awake is protected. So basically, you can just use that for awake. But if you notice, the init itself, the init method is actually public. The reason why is, let's say your character died and is respawning and you want to reinitialize physics controller. Well, you can just call init. Do note init is actually called from the awake. So init happens first and then awake. And basically base init can be useful for like setting up different like custom physics settings for your character controller. And then you have a fixed update. The fixed update itself is actually just overrideable. You can see here, I just keep track of like direction for last frame, and I actually get rid of that. Inside the fixed update, there is a pre-fixed update, so you can actually override this if you need to do any calculations before entering the physics checks. So after this is actually run technically before collision checks are actually done. So like checking if you're colliding to the left, right, up, down, and stuff like that. So if you need to do anything in your custom controller that happens before all those collision checks, you can just override on prefix update. And then you have your calculate horizontal loss, or horizontal and calculate vertical. The reason why I have these as abstract is example, you might have a custom character body for ghost-like enemies. I actually do have that. In fact, if I actually go here, let me actually show you. It's just to show this off. Oh yeah, I forgot. I was messing around with the blood zombie and I broke his AI. If you notice, the skull can actually go through stuff. So the reason why I have this as abstract is you can actually inherit from this, create a custom controller that does not do collision checks for like calculating horizontal and vertical velocity, and he can just float in the air. So it can be useful for stuff like that. Specifically for the skull, just in case anybody's actually wondering, he actually has a AI path state. If I actually go to scene view, this might be a little bit, yeah, there's actually a multi-threaded pathfinding grid that I have him following, and the bats also follow it as well. So there's a use of that. And there's freeze controller. This is actually how you set it is frozen and stuff. And also, when you first freeze controller, it sets both external and calculated velocity. And then you do unfrozen as well. There is a set of methods for setting external velocity and setting directional velocity, directional force. Do you know some of the force and velocity methods are actually do have a little bit of difference? The set directional force, the reason why it's not called set external velocity, the force is added in the direction you're facing, where like whatever you set the velocity to is whatever your velocity is. There's also methods for adding velocity, add horizontal velocity. These methods specifically override the external velocity. So like remember when I said earlier, I have a little mushroom that you can jump on and it bounces. Basically, I'm just overriding I'm just calling some methods like add velocity and so forth, and just adding vertical velocity. Yeah. Oh yeah, I was actually, ignore this method. This is actually going to be changed to calculated.x. I was actually testing out things. So this is actually going to be, this just heads up. I'm still working on the current update. But yeah, you'll notice that there is some like repeated functions like add vertical, add horizontal, and then there's like set. So if you want it to be a certain value, you can just set the velocity and so forth. And the reason why I'm not just allowing people to just like directly access the calculated velocity, there is some action, C# action and events that actually run on certain calculated velocity stuff. So I don't want them like set directly. Anyways, you can also set direction as well manually. This is actually used inside of the input system. So the reason why I have this here is, for example, let's actually, you know what, let's grab the patrol AI state. So this is actually on a zombie. So earlier I mentioned that you can, here's a good example of like the setting direction. I have it where you can actually set callbacks inside a controller body specifically. So if I actually go to a controller body that inherits from PhysicsController, there's actually a set of callbacks for if you collide on left this frame, if you collide on the right this frame. So if you want to have it where you check for certain collisions from certain directions per frame, you can actually do that. And basically, the zombie, he checks whether he hits a wall to the right or left. If he does, he just changes direction. And yeah, so as you see, like it's flexible. It may seem like it's kind of over extracted, but that's because it allows you to just do a lot of stuff. I was aiming for flexibility over anything else. But yeah, so going back to the physics controller, the last thing is a abstracted method for calculating movement state. And basically, as I mentioned, you can override this stuff for different types of controllers like the zombie and so forth. If I actually go to the controller body 2D and actually let's go to the player controller where we're actually using this. So inside the player controller, which inherits from controller body, which does inherit from physics body, so you see like the same thing is being used for character and the zombies. If we actually go calculate movement state, you can actually do some state calculations here. You'll notice that this is kind of where we do the post-collision. So calculate movement state happens after all collision checks. So like once a collision check is done, you can actually check to see like, okay, am I grounded? Okay, well, then you can start like setting up like the movement states and everything. And here's the first calculate movement state that actually overrides the PhysicsController2D. I don't mean to move that. And basically, you can see here, check to see if we're dead. If this is where it sets the movement state to climbing, velocity and stuff like that. So you can literally like override this and choose what states enemies can actually get into movement wise. Like, can they climb? Can they idle? Gliding. So you can actually see like set movement state gliding and so forth. And for anybody wondering like why do all this, so the movement state stuff here is actually read by the animation system, and it actually sets up the animation system for me. So like if I actually go to like the player animator and actually open this up, I can actually, let's go to to turn off auto link, that way it doesn't like automatically do it. If I actually go jump state here, you'll notice there's a gliding state, falling state. So I can actually use this to automatically set up animators. That feature is not fully done yet, but the goal is I can make it where people can actually choose a set of states a character or object can be in, and it'll automatically set up the animator for them. That's going to be one of the last features I do before entering beta stages. But I plan to make it where people don't have to set up the animator manually. But yeah, and again, you can see here, this is where I'm overriding the awake. And that's pretty much it for the physics controller. I'm going to make a separate video dedicated to controller body and the player controller. But basically, the PhysicsController2D is the base class for any type of object that needs to be interacted with physics-wise. And it's kind of, it is an abstraction heavy, but like I said, I wanted flexibility because I would like to point out like how flexible this is. Okay, so this same code is running inside of my platformer here. That same code is actually the same thing that's running inside of my top-down Legend of Zelda like remake for Oracle Seasons. Literally same code, except for 2 lines inside the controller. I had to switch the reference speed to vector 2 because top-down actually uses up and down for movement, not just like left and right like a platform would. But other than that, for the most part, the same code runs. It works exactly for Metroidvania platforming, and also works for top-down games like Legend of Zelda, Tunic, and stuff like that. So very flexible. Yeah, that's about it. This video's gone on a little bit longer than I was hoping. There are going to be some changes. I'll update this video, and when I do update the video after changes, this video will probably be a lot shorter. Someone just asked me to if I could like give a rough overview of some of the stuff. So these videos are just meant for a rough overview right now. I'll be making actual dedicated, like clean, professional looking tutorials later. Well, I'm calling it.